Hello, everybody. This is to help you with a portion of today's, or rather this week's discussion, which is about the weight of the matter. The graph for Mr. DB Jr. is given here. I've shared the URL of this graph with you so you can play with it directly. Now, the reason I picked 191 pounds for Mr. DB's starting weight, remember what we're trying to do is figure out in this whether he will be able to pass the recruiting camp or not. Now, you know this better than I do, but in the article, it says that the Army allows recruits to be 6% above the target weight for their age and gender when they start. And so I assumed, as I said in the article, that Mr. DB was 20 years old, 5 foot 10 inches, and his target weight is 180 pounds. So 6% added to that gives 191 pounds. And so the idea is, can he get from 191 pounds to 180 pounds in 12 weeks, which is the duration of the camp. So for the first 7 weeks, his weight is plotted here. The weight is in pounds along the y-axis, and the number of weeks elapsed is here along the x-axis. It starts at 0, 1 is here in the middle, then 2, 3, and so on until 12. So 1 week will be 2 of these divisions, and 1 pound will be 2 of these divisions. You can figure it out yourself. It's not that, and you can unlock the viewport here so this is the graph setting that says lock viewport. You can unlock the viewport if you want to zoom in and out, etc. Okay, so the question is, how are we going to do this? So Mr. DB Jr. is losing weight at a certain rate, right, which you can see here. Okay, that's great. How do we know what that rate is? Now, in your lectures that you got, you can figure this out by picking a point and then measuring its x and y distances from the origin and dividing the vertical distance by the horizontal distance, and that'll give you the slope, all right? Another way to do this, which basically is just a graphical way of doing this, is you learn the equation of a straight line in your lectures, which is y equals m star x, and well, we'll put parentheses around this portion just to show that this is one term, plus c. And Desmos allows you to add sliders. So when you type in m and x, it knows that y and x are variables and that m and c are constants. But you can change the values of those constants. That's not as silly as it sounds. A constant means that the value of the chosen value remains constant for the duration of the equation, if you will, whereas you vary x and y. So m and c are parameters. These are constants. They're called parameters. Okay, so let's just add sliders for these. What this does is it allows you to change the value of the sliders while keeping the plot of y versus x. In this case, y is the starting weight and x is the number of weeks elapsed. Now, the other thing that you can do is, right now this is having a problem. You're not seeing the line represented by this equation on the screen because I am zoomed into the point where I can see just the weight. If we sort of unlock the viewport like so, and then go back here and I scroll backwards on the thumb wheel, I'll eventually see this, right? So it's not that big a deal. Then you scroll back in and you can use these plus and minus buttons also to do this thing. I just find it convenient to use the mouse wheel to get here. So we'll get back to this point, and we'll log the viewport, and I'll show you how to move that line up. So let's do the locking first here. Maybe I'll zoom in a little bit more, right, just so we can see things more easily. And now I'm going to lock the viewport again. All right, so the reason the line is so far down below here, somewhere in this region, is because we are saying that the intercept of that line, that is the point or the span along the vertical axis, is just 1 unit in this graph. Well, I mean, here we are 180 plus units around over here. So I need to be able to move this over to 180 at least, right? Let's get it to the target weight. So now if I move the slider back and forth, it just goes so far. Well, okay. So we are kind of sort of onto something, but it's not working really well. Okay. And I also realized that I should zoom out a little bit simply so we can see the ending weight, which is in week 12 here. All right. Yeah. So much for that. Okay. Lock it again. All right. Now, the way to give you a larger span on the sliders is you just left click here in this region, just past the last digit, and you will see this thing pop up. Now, we'll go from, I don't know, 175 to, let's make it 195 just for convenience, and so that it spans the range of weight that we are interested in. Now you can see that the blue line is showing up and it's intercepting the y-axis at 175, which is what we put in here. Now, if I click back in here, oh, sorry, the 195 is here, and I'll change the slider values by 1 unit at a time. So 175 starting, 195 ending, stepping by 1 unit. So I'll click back over here and then back out here in this region, and it causes the slider to pop up. Okay, so now we can move the slider up and down. Okay, that's great. Now we come to the part of, wait a minute, line is going up and to the right and down and to the left, whereas Mr. DV Jr.'s weight is going from upper left to down at the right. How do we get there? Well, what does that mean when this thing is going downwards? Think about this a little bit. Go back and review your lectures, right? It has something to do with slope. Okay, and the sign of the slope, right? We take it that a positive slope means that the line goes from the bottom left to the upper right, right? And therefore, a line that will go from the upper left to the bottom right should have a slope opposite of this line, right? And having the opposite slope means that that slope should have a sign opposite to the sign of this line, right? Now, the slope of this line is m. It's conventional to designate slope by the variable m. M is positive, and its value is 2.5. Now, this is the slope. It's a ratio. It does not have units. This is not the angle. In order to get the angle of this line, you will need to take the inverse tangent of this value 2.5. But we're not going to get there yet. It's not relevant to this particular discussion. So we're just concerned about the slope. So what I'm going to do is I'm going to start moving this slider to the left. First of all, well, let me change this. So what shall we use for the slope? Okay, we saw where the 2.5 was. Just for the heck of it, we will go from a slope of minus 2.5 to plus 2.5, and we will increment or decrement the slope in steps of 0.1. All right, and we click back here or click back somewhere here, and voila, we have a slider. Okay, so now I'm going to go back down a little bit. And at 0, you'll notice the line becomes horizontal, okay? That makes sense. That means it has no slope. It's 0 slope, actually. Strictly speaking, no is a null value, but 0 is a specific value. The line at this point has 0 slope. It's completely horizontal. Okay, so, but it's down here around what? This is 175, 76, 7, 8, 9, and then 180, right? Because I zoomed in, so now the units are 1 pound per division here along the vertical axis. So we are sitting right here about 178 pounds. How do we get it closer to 190? Well, if you move the slider, and it's easier to see the behavior of the line and its intercept, right? So now the slope, it's intercepting the vertical axis at 180. Now I'm going to start tilting the slope again. Remember, when it was positive, it was going up. We want the opposite slope. We want it to be negative, so it's going down. And now it's great. It's here, okay, but yeah, it's kind of not where we want it to be. So what do we need to do? How can we get this line up to this point here at the starting weight, 191 pounds? How do we do that? You know how to do that. 191 points at the beginning of camp, right? At week 0, if you will, or the starting of week 1, it's 191 pounds, and we need to get our line up there. And the line currently is intercepting the y-axis at 180 pounds, right? And we know that the intercept of the line, which is defined by y is equal to mx plus c, the intercept of that line is c. And I have here a handy dandy slider that will allow me to change the intercept, okay? So I move the intercept higher, all right? Pretty soon, here I am at 191 pounds. The line is intercepting the x-axis, the y-axis at 191 pounds. Well, this is cool. So we are at the starting point. We have one more problem, though. Clearly with the slope of the line as it is shown over here, there's no way Mr. Devi Jr. is going to get 100 to 180 pounds in 12 weeks. Let's unlock the board and just see it where he would hit that weight if he was going to be losing weight at that rate. Holy moly, it's going to be a long time, right? He's going to get to 180 pounds around what it is. What is this? It is not. This is 30 weeks. This is 25 weeks, about 27, 28 weeks, or, almost 2.5 times as long. Well, that's not good. As you as the drill sergeant have to really have a heart-to-heart talk with him saying, hey, you got to shape up, man. I mean, literally and figuratively both. But in the meantime, to figure out what rate he should be losing his weight. The rate is the number of pounds lost per week. We ourselves, or rather you in particular as a sergeant, needs to figure out what that rate should be. Now, where is the slope represented in this graph and on this within this equation and in this plot? All right, let's log the viewport again just for convenience, I guess. I like it like that. We go back and we lock it. This also illustrates the point that you can play around with the graph and fit it to the point where it makes sense for you. This is a learning tool, okay? It's not something that you must do. This is a tool that you're playing around with in order to learn the concept. So we can do anything we like. We can change the units, we can change the magnification, we can play around with the slopes and so forth. A hard data, which is hard in the sense that I made it up and put it in here. Here's the table. I'll show you in a moment how to get to that table. But right now we're worrying about the slope. So let's change the slope of this line. The slope, as I mentioned earlier, is represented by the parameter m, right? And right now we've got the direction right. Mr. Devi Jr.'s weight is decreasing with time, but we need to get him to hurry it up a little bit. So we're going to increase the magnitude of the slope. Okay, magnitude means the size or quantity, if you will, right? But its sign will remain negative because we still want the weight decreasing with time. So I'm going to take the slider and I'm going to start moving it to the left. Now remember, my starting point here is fixed because my intercept is fixed at 191. What I want to do is tilt the slope enough to have it intersect his ending weight at 180, right? So let's go back here. Okay, now it's not moving a hell of a lot, or rather it's going past. I can't quite hit the target. So given that I've given you all the answers right now, there's not much point to this discussion. I'm going to leave this part as an exercise for you. How are you going to get the line to hit the ending weight, and what will be the slope at that point, right? What will be the rate of weight loss for Mr. Devi? That is the number of pounds lost per week. I'm going to end this here and leave it for you as an exercise. This is the part of getting this line to hit this target here on this graph is strictly becoming familiar with the tool and being able to manipulate it. There's no particular mathematical thing here. It's just playing around with the tools and the handles, so to speak, or features it gives you for making the line do what you want it to do. Okay, so there's that part. Going back up here, how did I create the table? If you click on the left-hand side here on the plus sign, it gives you a choice of inserting various things. So I just clicked on this table part, and it brought up a blank table with X and Y pre-entered at the top. And then I just entered a number here in this thing on the left-hand side and under X's, and then the number under Y here on the right-hand column. I can change this, for instance, anytime I want. And now you can see the way it's being shown here at 192. I'm going to put it back at 191, I think. Wasn't it that we were at? Oh, no, 191 was here, the 0 point, the starting point. This, important point to note. This is showing the end point, or the number of weeks elapsed. So we're starting at 191. At the end of 1 week, Mr. DV Jr. better have lost some weight, or you as the drill sergeant is not going to be terribly happy. So we're just going to make it 190.5. You can change these numbers around. There's nothing fixed about it. You can choose a different starting point. I am not familiar with the rules of the military, but you are. Some of you are, at any rate. And so you can, or you may choose a candidate who is a different height and starting weight. Plug in those numbers here and figure out what the rate of weight loss is going to be for those candidates. I'll place this URL. You already have it in here, but I don't think that particular link has the equation in it. You can click on that link and key in this equation yourself. That's good practice. I will also add this URL. Let me copy it now. You click in the address bar here, and a single click will highlight the whole thing. And then you can either right click and copy, or you can use Control-C if you're on a computer, and either way, it copies this thing, and then it's on the clipboard, and you can place it wherever you want. So I'm going to add this in here. Okay, let's do that. May as well show you how I get here. All right, you don't have this capability because you're not a faculty member teaching this course, but I do. I can edit the topic, and hopefully it comes up. And we will put the second URL here. Oh, I got to do a Control-V, right? I can right click and paste, or again, as you saw here, I can do Control-V, which is not working. So we'll go back and try it again. I think somewhere along the line I lost this. Come back here, Control-V. And there we go. Now it's already hyperlinked. So those are not things that you have to worry about. I'm just going to add in a line saying the second graph has a straight line equation programmed in. The second link leads to a graph which has a straight line equation programmed in. And now I'm going to right click on here just to correct the spelling. I don't know. Fine. I'll accept the suggestion from the browser to put a hyphen beneath it. That's fine. It's okay. Now we save and close. And voila, you will see it in here. Here we go. If we click on this, hopefully it's going to show up here. And why isn't it showing the straight line? Oh, you know why? Because this is important. Because I'll ask you to be sharing your graphs. So having these mistakes in here that I'm making is a good thing because it'll help you to avoid the same mistakes. I have to save the graph, right? And when I save it, doggone it, it changes the URL again, all right? So we'll go back. This is tedious. It works the same way as the last time, but I want to show you one more thing, which is if I ask you to share a link to your graph, what you do is you go to your graph, you save it, okay? You must save it, and you need to create a free account on Desmos in order to be able to save things. But there are two ways to go about sharing what you've learned. One is you create an account, and then you click in this arrow, Share Graph, right? And it brings up this pop-down menu. You can simply copy the link, and then you do the same, either paste or Control-V and into whatever your document, and you share the link, and then it leads people to this graph. That is an active graph. In other words, people, your colleagues, your classmates, I can go in and change the numbers to figure out what's going on or to play around with it, and that's a good thing to do, okay? The second way, which I don't believe requires having a login, is to, instead of copying the thing, I just click back out, but it's the same thing. You say export image, right? And what does that does is the system automatically takes a screenshot not of your screen, but of this graph. In other words, Desmos takes a screenshot of the graph, and you can change things around, the size, yada yada, and so forth. But basically, then you click over here and click download as PNG, right? Or don't pick SVG. It's a different image format. You don't need it, right? Download this, and it'll bring up a directory or a folder on your device, and you can save it there then. All right, that's it. Let me know if you have questions. I encourage you to ask questions. As soon as you have problems with anything, don't let it sit and simmer. Okay, it doesn't help you. Get your questions in as soon as possible. Post them right to the weekly discussion board. That way I can answer and other students can see it. And in fact, even other students may be able to answer if they know the stuff already, and you can see it along with the remaining students. All right, good luck with the rest of this assignment. Now, change this around a little bit, right? Because I've basically, the standard thing posted in the discussion post, I've given you the answer to that, okay? It'll be no fun seeing the same thing replicated, right? So change the starting weight, play around with whatever it is that you like with it, but do something a little bit different. Thanks.